I'm Caroline, welcome to my channel. Today, with this video, I'd like to read you from this book, The Earth, Oceans, Continents and Universe. And thank you for joining me today, and I'm going to read the section on threats to the environment. And I hope you enjoy it. In recent decades, many protective measures have been taken to limit the extent of natural catastrophes as far as possible. There are now alarm systems in the Pacific that can give early warnings of tsunamis, the great waves that suddenly inflict destruction on coastal regions. Efforts are being made in Japan, China and the United States to predict impending earthquakes with a network of observation posts. Areas threatened by flooding are excluded from the very beginning from plans for construction work in order to prevent catastrophes at a later date. However, a threat to the Earth still exists. Humanity itself. Poisonous substances in industrial and agricultural waste products pollute the soil, the groundwater and the seas. During the production of many synthetic materials, highly poisonous gases are emitted that reinforce the greenhouse effect and cause smog. Whole areas of countryside are deforested and rivers made biologically dead by the increase of acid rain caused by the emission of CO2 from cars and coal-burning stoves. In order to avert an environmental disaster, it is not only necessary to change our ways of thinking to be, but also for each individual to act in an ecologically aware manner. Acid rain. Sulfur dioxide and carbon dioxide are components of unpolluted rain. Rain is naturally acidic, a consequence of the sulfur emissions of volcanoes, but also of the composition of air. Air contains traces of dioxides in the form of gas. The natural acid content of rain does not damage the environment. However, the situation has changed with increasing industrialization. When fossil fuels such as coal and oil are burned, additional sulfur dioxide is released. The wind spreads the dioxides, which are converted into sulfates and nitrates by the sun's rays. Acids containing nitrogen and sulfuric acids then collect in clouds and return to the Earth's surface via rain or other precipitation. In this way, the acidity of rain increases by up to 500 times compared to its natural state. For a time, the soil can resist these harmful influences if neutralizing chemicals such as calcium, for example in limestone, are present. Nutrients such as magnesium or calcium are reached from the soil by acid rain, however, leading to damage to the trees. Coniferous forests are especially badly affected. The situation is aggravated in winter when acidic snow lies on trees. As a result, nutrients are drawn directly from the needles of the trees. When the snow melts, the acidic water goes into the soil and damages the roots. In this way, trees are harmed by poisons in the environment. If other damaging factors such as pests or periods of drought are added to this, the weakened trees die. Acid rain affects not only trees but also buildings. The stones of historic buildings can even be eaten away by a high acid content. When the bed of a lake is rocky, the sulfuric acid cannot be neutralized due to a lack of calcium. In consequence, the lake becomes acidic, leading to damage to plants and fish. Many areas of European forest have been affected by this damage to trees. A change seems to be taking place as a result of increasing environmental awareness. The installation of filters in industrial plants for removing nitrogen and sulfur, and the inclusion of catalytic converters in cars. In South America, Africa, Asia and the Indian subcontinent, by contrast, industrial growth is proceeding so quickly, with environmental regulations often being ignored, that the effects of acid rain are particularly noticeable there. Acid rain arises through the general spread of industrialization. When fuel is burned, increased quantities of sulfur and nitrogen oxides are taken into the air. In combination with sunlight and the atmosphere, they produced raised levels of sulfuric acids and nitrogen oxides. These poisonous substances return to the Earth's surfaces with the rain. The forests are damaged when these substances are deposited on trees or seep into the ground. Industrialization, mountains, lake, acid rain, sulfur, nitrogen oxide, emissions, sulfuric acid, nitrogen oxide. The greenhouse effect. Life would not be possible on our planet without the natural greenhouse effect. The sunlight can penetrate a glass house practically unhindered and warm it. However, the radiated warmth that is produced cannot escape again through the glass without hindrance, and as a result, heat is stored. A similar process takes place in the atmosphere around us. It is composed of various gases, 78% nitrogen, 21% oxygen, 0.9% argon, 0.04% carbon dioxide, and trace gases. 50% of the sun's radiation reaches the surface of the Earth unobstructed and warms it. The heat Earth radiates warmth back again, but as in the greenhouse, this heat radiation cannot simply escape through the atmosphere into space, but is held back. Water vapour and carbon dioxide are mainly responsible for this. They absorb the radiated warmth and return it to the Earth. The average temperature on Earth is at present about plus 15 degrees centigrade. Without the greenhouse effect, the average temperature would also be 15 degrees centigrade, but with a minus sign in front, i.e. 15 degrees centigrade. Human activity has led to an increase in the greenhouse effect over the last decades. Industry, traffic, and agriculture have caused a rise in the greenhouse gases. These gases reduce the escape of heat radiation into space and radiate a part of it back to the Earth. The more greenhouse gases, such as carbon dioxide or methane, are present, the more heat radiation remains in circulation between the Earth and the atmosphere. The result is a slow but steady warming. "50% of the sun's rays reach the surface of the Earth and are radiated back again by the warmed Earth. Solar radiation. Water vapour and carbon dioxide are an obstacle to the escape of heat radiation back into space. Earth surrounded by atmosphere. Hole in the ozone layer. Ozone is a relatively rare gas and a poisonous form of oxygen. It consists of 3 atoms in one molecule. In oxygen, by contrast, there are only 2 atoms per molecule. Ozone is present throughout the atmosphere to an altitude of about 50 kilometers. The layer with the highest concentration of ozone, or ozone layer, lies at a height of about 25 kilometers above sea level at low latitudes. Towards the polar regions, the height of the ozone layer decreases. The short wave component of ultraviolet rays causes oxygen to be converted into ozone by a photochemical reaction. As a result, the ultraviolet radiation which damages cells is mostly absorbed. The use of hydrofluorocarbons as aerosol propellants and in the production of foam results in the damage to the ozone layer. Ozone is able to oxidize hydrofluorocarbons and in doing so is reduced to oxygen again. Ultraviolet rays, concentrations dangerous to humans and animals, can reach the Earth's surface when the ozone layer is damaged. Hydrofluorocarbons have a very long lifetime and can result in damage to the ozone layer many years after their release. At low temperatures, this process of damage is especially obvious. A noticeable depletion of ozone has been observed in the Antarctic winter in the last few years. This condition is known as the ozone hole. Destruction of the ozone layer. Earth. The influence of human activities is gradually destroying the ozone layer in our atmosphere. The main harmful substances are hydrofluorocarbons, nitrogen oxides, and sulfuric acids. Changes to the Earth's surface. The external appearance of the Earth's land masses is in a state of continual change. If forests are cut down for their timber or cleared for agriculture, whole areas of land can eventually become barren. The roots of trees hold the soil together and store water. In this way, they prevent precipitation and wind from eroding the soil. Moreover, as a result, rain does not seep into the earth, but is put back into the air through leaves. In the past, fields were not used in a balanced way. As the cereal planted was always the same type, agricultural land was also over-fertilized in order to obtain better and higher yields. The result was that the soil dried out or became unusable. The construction of dams and regulation of rivers to make them navigable alters the environment. The face of the earth is also changed by the extraction of minerals, which lowers the ground level, overgrazing by herds of animals, and road building. Efforts are also being made, however, to make a favourable impact on the appearance of the landscape. In North Africa and the Near East, projects have begun to make infertile land suitable for crops by means of sophisticated irrigation systems. Reforestation is going ahead in many places, and especially in the Netherlands. Attempts are being made to create new land with gigantic dikes. More than anything else, however, it is the forces of nature that change the face of the earth. Climate changes subject the land to different temperatures. Wind and rain erode the soil. Deposits of sediment, weathering and erosion create new landscapes. Lastly, plate tectonics, i.e. the shift of land masses, throws up ranges of mountains and pushes continents into different climatic zones. These changes to the surface of the earth proceed constantly but very slowly. If large areas of forest are cut down, the open spaces are exposed to weathering and erosion. The land inevitably becomes barren. In contrast to this, the natural equilibrium is preserved in a forested area. The soil is held together by roots and is thus better able to absorb water. Water is returned to its natural cycle through the leaves. Rain. Land becomes barren. Erosion and weathering. Soil, well provided with roots and rich in nutrients. Preservation of the natural equilibrium. Climatic change. When unusual weather phenomena occur, one question is soon raised. Has the climate of our Earth changed significantly in recent years? Following a cooling of the Atlantic and a fall in temperatures in the northern polar region in the 1960s, some scientists announced the beginning of a new Little Ice Age. These observations alone were not sufficient, however, as proof of a general cooling of the Earth. Today, the issue under discussion is whether there will be global warming in the coming decades. Warming could be the result of human intervention, by means of which more and more greenhouse gases, such as hydrofluorocarbons, methane and carbon dioxide, are released into the atmosphere. Greenhouse effect. Natural events too, such as a shift in the position of ocean currents or a change in the flow of ice into the ocean around Greenland, could have an effect on the circulation of air and thus influence the climate. Altogether, there has been only a slight rise in temperature so far. Climate researchers must look for evidence for a change in global temperatures by using the climatic data of the last decades from all over the world. This includes interpretation of particular events such as droughts, cool and rainy summers, or mild winter temperatures. This analysis and predictions of climatic changes and their effects in the coming years are important areas of work for climate research in the future. Disturbance of the natural equilibrium, emission of poisons, rain of gases and ash during volcanic eruptions, destruction of the ozone layer, meteorite impacts. The Earth's climate in the future is dependent on various factors. Human intervention, such as a high energy consumption and the consequent high level of emissions into the atmosphere, could lead to changes in the reflection of sunlight. In the long term, this would result in global warming. On the other hand, natural events, such as volcanic eruptions, could alter the chemical equilibrium. Their gases and ash create a shield in the atmosphere that allows less sunlight to reach the surface of the Earth. And that's where I'm going to end the video. I hope you enjoyed it, and if you did, please join me for another video soon. Thanks for watching. Bye.